This is Euclid Book 2, Proposition number 5, Part 1. Now, before we get into this, I wanted to show you this little equation. You see this equation here that says x squared plus 2xy plus y squared equals x plus y squared? This was clearly illustrated, and if you'll watch the previous video, you'll see this for yourself. This was clearly illustrated in Euclid Book 2, Proposition number 4. Okay? We're going to go on with Euclid Book 2, Proposition number 5. Now, the first thing Euclid has you do is he has you draw a line from point A to point B. From point A to point B. And then he wants you to bisect that line. Do you remember how to do that? If you don't, you have to go back to Euclid Book 1, Proposition 10, because I'm not going to discuss it here. Alright? Now then, let's go on. You've bisected the AB line, so now you have a length that's AC. Okay, this length AC is equal in size to length CB. Using the length of CB or AC, the one, because this length is going to be equal to that length, you're going to draw a square using Euclid Book 1, Proposition number 46. And you're going to draw the square CEFB. Okay? Once you do that, you're going to bisect the square. And I'm sure from a previous Euclid proof, you can remember how to do this. You're going to draw a line from point B to point E. And then Euclid says he wants you to unevenly create another line from point D to point G. So you just pick some point, some random point between C and B, call it D, and then draw your line from point D to point G. Now, line DG intersects line BE, and it intersects it at letter H. Okay? And where it intersects, you're going to draw a line from point M through point H, through point L, and all the way to K. Alright, so now you're going to have a line KLHM. Alright, now you have drawn the shape you need to draw in order to prove your proof. So what are we going to prove exactly? Well, hang on just a second here, because I'm going to tell you what we're going to prove. Alright. Well, this is going to be kind of a long and complicated proof, but what we're going to do is we're going to say that if you were to add this and this together, you're going now we're talking about areas here. If you're going to add the area of this and the area of this together, you're going to get the area of CEFB. Okay? And I'm going to tell you exactly how to do this in my next video. So stay tuned.